Yes, student. So today we will see the our topic that is the concurrency control. So in the concurrency control, we will see the log-based protocol. This is again an important point where we will discuss the concept properly with help of some examples as well. In our previous class, we have seen what is mean by the transition and what is the transition management can do. So if you remember the some terms, if you remember the view, if you remember the serializability, B equivalence, result equivalence, okay, conflict equivalence, conflictibility, we have seen. Before starting the concurrency control, let me explore some more idea so we can start the concurrency control properly using log-based protocol. What I am using right now, I am using this diagram. This diagram is just given the reference of the equivalence we have seen so far. On the request of the student, I have drawn a diagram, randomly diagram over here. So I am taking the two transition T1 and T2. This is an important point you people are required to listen carefully. Once you miss the step, then you are not able to understand the concept properly. So I'm just taking the rough data only, T1, T2, two transaction I'm taking over here. Equivalence, we have the three types as we have discussed in the previous class, result, view, and conflict. So in the transaction T2 and T1, what I'm taking the random read and write operation and random data item, that is the A and B only. So first I'm talking about the right now result equivalence. What is result equivalence is saying to us? And you will not think about right now, sir, this part we already discussed, so why we are discussing. This is just only the revision of the previous class. And this slide is more important for moving to the next part as well. So result equivalence is saying to us, as a black color, you can also observe that the final value of A, B, C, what would be. So based on the read and write operation from the each and every transaction position, we can easily determine what is the what is the final value of the A, B, C after performing the various operation on these data items. So this is to be identified by the result equivalence. So result equivalence is saying to us if I am having the transaction T1 and T2 and I'm using the different schedules, two different schedules. One is the S1 and other one is S2. Just like you can observe over here. This is our two schedule I'm taking right now. One is the S1 that is followed by the T1 of comma T2 and other schedules that is the ST2 comma T1. So if I'm using these two schedules, first I'm executing the T1 and then I'm executing T2. But what you're observing over here, this is concurrent execution we have over here. So first I'm executing T1, then I'm executing T2, and then I'm executing T1 and then T2 and then T2. So this T1, T2, T1, T2 is moving here once again. So this context switching is going between the T1 and T2. So I'm using the first T1 in T2 and then T1, then T2 and then T1, T2. So if I'm getting the result of the S1 schedule of ABC value, suppose XYZ value I'm getting, then same value I'm getting XYZ value I'm getting from the S2 schedule, and we are choosing its order T2, T1 or T1, T2. So if I'm changing any order, but I'm getting the same value after applying the any one of the schedule. So this is known as the result scheduling. But there is no guarantee after applying the result equivalence, the result we are seeing that should be equal, but it should be equal. There's no guarantee every time you are applying the result equivalence, you will get the same result after changing the seek order of the transactions. But you are getting the same result after changing the order of the transition, then you will be damn sure about this point right now. Result equivalence you are having because the result you are having the equal way. So as one result, S1 schedule is returning some information and X2 result is returning some information. So we S2 schedule is returning some information. So we are having the ABC value S1 S2 is equal. So both results should be same. That is the point. So this result should be equal. Now talking about the view equivalence. In the view equivalence is what we are doing right now. You can observe over here RB and RB. That is a two read operation on the data item B we have from the transaction T1 and T2. Just think normally, if I'm trying to remove the conflicting operation. So what I'm doing right now, I'm applying the swapping. So on the time factor T, if I'm trying to apply the swapping operation on these two operations, that is RB and RB, so I can easily apply because there is no conflicting is over here. So if I'm trying to do so, because both transaction just want to read the information. So if it is possible, if I'm trying to do, so T1 and T2 or T2 and T1 if I'm doing, so result will not be affected. If I'm choosing the RB on the upside from the T1 and I'm just moving down RB read operation from the transaction T2 downside, then you will feel a result is not affected. What the result we are looking at the previous part as we are getting the same as it is, so we have the view equivalence. So by default, in the non-serial transaction, non-serial scheduling, if I'm transforming into the serial way, or if I'm using the any swapping operations by which I'm getting the sequential manner of the operation in the transaction. So what I'm following the view equivalence. It means my this schedules S1 and S2 is following the same view. So if this is just like example, this is a simple example after applying the swapping. So this is the S1 supposed it, and this is the S2 or any other schedule I have. So by which I am getting the same result. So it means I am applying the view equivalence. So my this schedule will represent as a view. So where is the conflicting is occurring? So this is a big question we have to in our mind. Where is the conflicting is occurring? As we know, in our transactions or list of the task, we have a conflicting operations. If we have conflicting operations, that is the point you people are required to understand properly. If we have conflicting operation, then it means we are talking about the conflict equivalence. But conflict equivalence is saying to us your information can be identified by as a conflict seriality. Before that, your schedule must be a part of the conflict equivalence. This is just like example over here, that is the RB and WB. So from the transition T1, I'm choosing the RB, so which is marked by me in the green color, and transaction T2, I'm picking the WB. So schedule one, schedule two, I am choosing over here. So I'm taking the it's a small part for explaining my idea. So on the bottom side, you can easily see over here. So S1, T1, T2, we have the RB and WB, and S2 we have the RB and WB. But I'm changing its position. So after it's swapping, how I can changing its position? Just only the swapping operation I'm applying. So after applying the swapping operation, I'm in changing its position. Then I'm finding my result was not affected. But these are the two different operation RB and WB. It means on the same data item, I was unable to apply the two different operation on my transaction because same data item cannot access the two different operation on the same day, two different transaction. So it will be confused by the or this our transactions over the our transaction manager will get confused on the data item I should write or I should read. So at the time we have a big problem over here. This is the issue. So to avoid the such thing, what you will do, you will use a serializability. So in the serializability, we have to transform, we have to convert conflict operations into the non-conflict operation, or by choosing the non-conflict operation, we can transform non-scheduling operations or non-scheduling into the serial scheduling, so we can get the execution of our transition in smooth way. So that is this is the three different things we have to keep in mind: result equivalence, view equivalence, and conflict equivalence. From this point, we have to start our topic. That is concurrency control. But again, I'm speaking once again. Before moving to the concurrency control, you people are required to understand the concept in simple way. So what the next slide is saying to us? Next slide is saying to us, unlike the conflict serialities, where we are doing, we are transforming our non-serial schedules into the serial schedules by using the non-conflict operation. So what are the conflicting operation we can avoid? So we have to avoid or we have to remove the conflicting operation. So here in the view seriality, what we have, so we have a two transaction T1 and T5. So if I'm choosing the this transaction T1, some part in form of the inconsistent state, same I'm applying on the T5 transaction. So you can see it could be the part of the conflict equations. If I'm just I'm applying the swapping. So you can see I have already marked by me in the circle way. Writing and read I can choose. So these are not conflicting, but I'm just non-conflicting operation I'm choosing. So so what we have, there will be no issue. So write B and read A I can choose, so there will be no issue. So view seriality is saying to us you are just able to view only the in the our list of the schedules or transaction when we don't have any conflict. So we try to see what is the seriality we can apply. So if we're trying to apply the seriality, it means transformation we're applying. So this is just known as the view seriality. By default, what is the schedules we have in our transactions that is to be part of the view seriality. If we are applying the transformation, then we have the view seriality, else we have the view schedule, and all these are managing by the transaction manager. So that is the point we have to keep in mind. So in our system architecture we have two harder term: transaction manager. The transaction manager also deals with kind of the these kind of the functions. So be considered a form of the equivalence that is less stringent than conflict equivalence, but that like conflict equivalence. So here we can also have the conflict equivalence. There is some chance we can have. So in the view seriality, we can say a view seriality can be a part of the conflict seriality, but reverse part is not possible. So that is the point we have to understand step by step. Just tell me right now, any problem over here? So this is the all these terms we have to keep in mind. Let me clarify all these terms once again here with the help of the theory portion. So the concept of the view equivalence leads to the concept of the view seriality. The concept of view equivalence. If you don't know, have any idea about the view equivalence, then you are not able to understand the view seriality. So same example, conflict equivalence you don't know, then you are not able to understand the conflict seriality. So we say that a schedule S is a view serializable if it is a view equivalent to the serial schedules. That is the point. So we say that a schedule S is a view serializable if it is a view equivalent to a serial schedule. That is important terms we have to keep in mind. So the diagram in the diagram we have a three different architecture, three different transitions. One is TU3, T4, T6. In the next slide you will be able to see. Now see observe over here. But let me read all the points over here for note purpose only. So diagram which is marked, which is drawn on the next slide, it describing that is the it is view serializable. So in the view serializable, there is no guarantee we will have a conflict serializability or conflict we can. So we in the view serializable there is no guarantee we will have the conflict, but in the conflict there is a guarantee the conflict operation should be there. So I'm just focusing on the my board right now. So indeed, it is a view equivalent to the serial schedules T3, T4, T6 are the three different transactions. So since the one read queue instruction reads the initial value of the queue in both schedules, and T6 performs the final outright of the queue in the both schedules. So every conflict serializable schedules is also be a part of the view serializable or is also a view serializable, but reverse process will not guarantee. In the view serializable schedule that are not conflict serializable level, that is the point we have to keep in mind. Let me now move to this point right now. Now, this is the saying to us, observe that in our this diagram, T3, T4, T6, we have these, all these are known as the three different transactions followed by the two different schedules. Suppose that. So in the transaction T3, what we are doing, we are reading the value of the queue and we are writing something. But in between the call of the T4 we got, so we are writing something on the queue. So what you are observing over here in the transaction T4, before writing anything on the queue or we are writing the queue value or queue data item, we are not reading any information from the queue. So it is determining that is a blank write. Okay, it is determining by the blank write. So these two operations in which in the transactions we are writing something. So this is to be identified by as a blank because we are not reading anything. So without having performed a read queue operations, writes of the this short is called the blind writes. So blind write appear in any view serializable schedule that is not conflict serializable. So this is the point you people are required to understand properly. Okay. So is it clear to all right now? Tell me, is it clear or any problem?
Clear, sir.
Clear, sir.
So what we have discussed so far, we have discussed equivalence. There are three kind of the equivalence: result, view, conflict. And after this, we have seen the view serializability. So view serializability is just by default what is the serializable we have, that is a part of the view serializable. But conflict is saying to us there must be conflict operations should be there. So how to remove the conflict operations? Just apply the non using the non-conflict operation. So we're transforming our schedules into the serial schedules. So this is the conflict seriality. Now this part we already discussed, but here we have this point. So write queue we have, but before write the queue in the T4 T6 we are not using the read queue operations. That's why this is not the blind write operation. After understanding this point, next point we have over here the implementation of isolation. Why I'm discussing all this point? Because the foundation to understand the concurrency control should be clear. Without doing all these things, you are not able to understand what is meant by the concurrency control followed by the log-based protocol. That was our topic. So implementation to isolation, we can understand over here in simple way what I have written over here in the my notes. So you can easily say so far what we have discussed. We have seen the properties of the schedule that must be satisfied to leave the database in a consistent state. But it is satisfying the our condition to leave the database in the consistent state. But also it allows the transaction failure to be handled in a safe manner. So from this point we have the isolation. So what is isolation? Isolation is saying to us if you are handling the information, if you are managing the information, but all the information we are managing the transaction, so all the information that are part of the one transaction or other transaction are not disturbing, not depending on the other thing. So just like simple example, I can speak over here. Now I'm remembering example. Suppose this is a transaction T1 and this is a transaction T2. So these are the two transactions. If I'm reading the information, read A. I'm reading a data item A by the transaction T1. Same transaction T2, just try to read some information from the A same time. So the point you people are required to understand, these are the two read operations performed by the about two transactions. So there is no conflict we have over here. So there is no conflict over here. But reading from a transaction T1, reading from a transaction T2 are different from each other. So this is what is saying to us, we are having the isolation information. So it means the information will be isolated. And the isolation is a part of the concurrency control mechanism. So when we have to study or when we have to heard this term right now, we are studying the concurrency control. So in the time of the interview, if anyone asks you what do you mean by the concurrency control, so concurrency control means in a concurrency execution of the transactions, how to control the concurrency execution of the transaction, and that is to be identified by our isolation property. So this is a real implementation to isolation. So that's why the term or highlighted or heading what we have, implementation of isolation. Okay, so now I'm reading the some points over here for a betterment. Specifically schedules that are conflict or view serializable, that is by the these requirements. So because and what is the view and conflict serializable we have seen. So there are various concurrency control schemes that can use to ensure that even when the multiple transactions are executed concurrently. Yes, of course, in the concurrency control schemes also applicable when we have the multiple transactions are executed concurrently. So only acceptable schedules are generated. So we will accept only the schedules which are required, that is to be acceptable only. So regardless the how the operating system time share resources such as the TCPU time among the transaction. And that is the point I'm speaking once again. While managing the transaction over the system, the operating system play important role to deal with all the kind of the issues or all the kind of the problems. Why? Because the transaction itself be a part of the process. So operating system is basically handle the all the process followed by some algorithmic steps, and this algorithmic step can be managed by the its process scheduling algorithm. So those are FCFS, round robin, where we have used to use the time slice. We have the priority, we have the shortage of first, okay, we have the SRTF, and we have the multiple queue. So there are lots of the queuing algorithms, queue scheduling algorithm we have by which we can solve our problem. So that is the reason here the implementation of isolation is applicable. Okay, so next statement I have written over here inside the implementation of the isolation. See, this is the saying to us what we have discussed so far. This summary of our part. So, as a trivial example of the concurrency control scheme is saying to us, consider this scheme. A transaction acquire a lock of the entire database of the before it starts. Just like this point right now, I can speak over here. Just like this example, I can speak over here. If suppose A is a person, I am taking simple example. A is a person, and B is another person. This is the database. This is the database of book a ticket. Okay, I am booking a ticket. This is my task. I am booking a ticket. So this is my database. I need to book a ticket, but this is my problem. What is my problem? There's only the one ticket is available. So question we have, this will get the first or this will get the first. So all these two systems are connected to the my database system, but there is only the one seat is available. So who will get the ticket? That is a big issue. So what is the problem? This is a problem which is managed by the concurrency control. So depend on the configuration of the A and B, something depend on the net speed of course. So all these are technical aspect what we are having or technical configuration what we have. Based on this parameter and based on our operating system of the database server, operating systems of the database server will also require to manage all these things. So A is sending some information to book the ticket. We also sending the same information to book the ticket. So depending on the operating systems process execution, this activity will be done. So what we have to do, I'm taking a simple example over here. So that's why the things we can easily understand. Now A got a chance. So A got a chance to book the ticket. So what happened? I will log the transaction. I will log the transaction of A. I will log the transaction of the A because A was entered into the database first, so B has to wait. B has to wait. B has to wait until until unlock the A's transaction. So I'm locking the my transaction. So what I'm doing, I'm just log the transaction. So when this transaction was logged, so no other person, no other process can intervene with the server. Now, this has happened in many times while booking the IRCT ticket on the IRCTC. Let me take a real story. So this has happened with me 2 days back. 2 days what happened? I was trying to book a ticket on the IRCTC. So I just found there are 288 number of the tickets are available. So okay, no problem. I decided to after the 1 hour I can book. After the 1 hour I checked there are the 220 seats are available, right? So no issue, I can book. But I planned, okay, now we have enough seats, so I can book after the half an hour or 1 hour. So suddenly I got an emergency call, so I was busy with my call. After the 20 minutes, I just trying to refresh the my screen. Again, I have to relog in because my session was expired. So after the expiring the my session, I'm trying to relog in on the ICTC website. Then again, I found over here, I'm observing there was the last status was the 220. So, but suddenly I have the right now the 240 seats. Now where the 220 seats are increased, the reason is clear. The more of the people are connected with the server and they trying to book the ticket, but unfortunately they may got the chance to cancel the tickets or they got the chance to hold their release of the transaction. So when they are unlock the transaction, so at that time I got a chance to book the ticket. And this is really happening with the while booking the ticket, the car booking ticket. So if you are booking the ticket, suddenly within the 1 minute, all the slots or all the tickets are booked immediately. That is the reason. So because while they are booking the ticket, they are connected to the database servers. So this the connection between the your machine and the server machine was locked by a transaction. So that is known as the locking. So from this point, we have a lock-based protocol. From this point, we have the log-based protocol. So what we are doing, with the help of the log-based protocol, I'm trying to I'm trying to control the concurrency execution of my system. That is the point. So this is the simple example I'm speaking here right now. So, but I found, okay, no, I need not to book the ticket. So unlike me, other person can also cancel the ticket, or other person can also release the or unlock the transaction. So other people can get the chance. And this is happening, really happening with me so many times in the June month or my month when I try to book the slot to get the vaccination of the COVID-19. So this is really happening in the real situation. And really, this is the thing. So now we are the part of the database management system as well, and we are the part of the concurrency control. Okay. So now this is a simple example, real example I have taken. Now it is clear to all right now. It is clear to all right now. So if until unless I am not unlocking my transaction and we cannot access the server, we can easily see the server what is happening. So it shows to the ticket was full, but while I'm unlocking the transaction, I'm decided I will not booking my ticket. So this one will be accessible to the B. So now we will see, okay, now he has a chance or she has a chance to book the ticket. That is really happening. So I'm taking only the simple example, one or two only, but in the our industry, in the railway system or in the banking system, we each and every machine, the highly configured system servers are dealing with the thousands of thousand transactions on a one moment, and that is really happening in today's era. Okay, so this is just idea about the concurrency control, from which where we have to start the logbooks protocol. But without the law, without the views, realizable, convertibility, basic idea of the equivalence, you are not able to understand all this. Okay, so now it is clear to all right now? Or any doubt you have, so please you can ask me right now. Yes, tell me, any doubt?
Yes,
No
sir.
doubts.
Okay. So now I'm just moving to the next slide. From this slide, we have to start the concurrency control. So what is a concurrency control exactly? So we saw that one of the fundamental property of the transaction is isolation. So what is isolation? We have already discussed this point many times. So isolation we have seen inside the implementation of the isolation. So that is an important point. The fundamental property of the transaction is, so please, I am highlighting this point. So please focus on this one right now. The fundamental property is, why it is fundamental property? Because it is a part of the asset property, and asset property is the more important four clear properties of the database management system, as I told you so many times. So this is the point I am highlighting over here. So your people are required to understand. So when several transactions executed concurrently in the database, however, the isolation property may no longer be present. That is the problem. So when we have the huge volume of the transactions at a time, this isolation may not be preserved, because the transaction that was a part of the consistent state will be coming to the inconsistent, and after the completion of the its execution, it change into the consistent. So that's why the isolation may not be longer exist, because the transaction was complete. That is the reason only. To ensure that it is the system must control the interaction among the concurrent transaction, and this control is achieved by through the one of the important variety of the mechanism that is called the concurrency control schemes. So log-based protocol is what actually this is our first log-based protocol concept, which is known as the concurrency control schemes. From this point, we have to start the what is a concurrency control. So what we have discussed so far, I'm speaking over here from my notes over here. So please listen carefully. Concurrency control in the database management system is a procedure of managing simultaneous operations without conflicting with each other. So that is the point you have to keep in mind. I'm speaking once again. Concurrency control in database management system is a procedure of managing simultaneous operations without conflicting with each other. It means we can perform the many read and write operation, and all the operation that should belong to the non-conflict operation. So that is the concurrency control will play important role. And it ensures that database transactions are performed concurrently and accurately to produce the correct results. without violating its data integrity. It means the relationship what we have inside the data that should not be violated. If it is violating, it means we are disturbing the features of the database as we have discussed in the first and second class. So data integrity was the important features. Why we are using the database management system? This part we have to discuss inside the our first and second class. That is a feature of the database management system. So data integrity should not be violated, and if it is violating, then our database is not a good. So concurrency control to maintain the data integrity. So we can see over here. So concurrent access is quite easy to for all the users are just reading the data, but there's no way they can interfere with another. So though the practical database, it would have a mix of the read and write operation. So as we have seen, what is the read and write operation? So I'm not discussing over here. But to manage all the things, to put all the details, it is basically a challenging task to handle all these things. Let me clarify all these terms with the help of the next PPT, next slide over here. Database management system concurrency control used to address such conflicts, which mostly occur with a multi-user system. Now, this is a practically because at the same time, I'm the person I'm booking the ticket, so I'm not the alone person who is booking the ticket. Unlike me, there are 1,000 people, more than maybe lakh people can book the ticket, or they are accessing the same database server. So that is the reason. So multi-user system means my machine is not a single machine which is accessing the IST server. There are lots of the machines which are interact to the IST server. That is it. So concurrency control is the most important element for the proper functioning of the database management system, where we have the two or more database transition. That is the point. So in the next slide, maybe you will see the three different transactions. Okay, so let us understand all these things step by step. Because so far we have the example that belong to the two transactions only T1, T2, T1, T5, and T2, T0. We can also put the T3, T1, T3, T4, T6, just like this one. Here, see T3, T4, T6. So here we have the three transactions. So here, as a for understanding purpose, we are just looking at the three transactions, four transactions maximum. But practically, we are not bound by the all these three limited number of the transactions. We are bound by the, or we may bind by the thousands or less of the transactions simultaneously. So all these things are managing in a simple way, in a simple manner, without disturbing or without losing any information. That is the beauty of the database management system. So that is a concurrency control. Okay, so this is the reason. So from this point, we have a question: why we have to use the concurrency method? I'm not dive into deeply, but I'm just giving you some idea over here why we have to understand the concurrency control. So what is the reason? After understanding the fundamental point of the concurrency control, so let me understand why we have to use the concurrency method. First, to apply the isolation through the mutual exclusion between the conflicting transaction. So two transactions which are conflicting, so they will maintain the isolation to information cannot be lost and to do not violate the data integrity rules. So that's why with help of the mutual exclusion, how we can do the mutual exclusion? There's nothing, just swap. Okay, swapping is the only method by which we can do. So there will be swapping between the two operations, but keep in mind the using the appropriate or proper non-conflicting operations. And to resolve read write and write conflicting issue. So when we have the read write, but at the this is the maintained by the same data item. But if it is read write is maintained by the two different data items, so there will be no conflicting. So that is the point. Write it, of course, if any one of the in the same data item, if any one of the write operation on the same data item, so we can say we have the conflicting. So conflicting mutual exclusion between conflicting transaction. It's like this. And third point is saying to us to preserve the database consistency through constantly preserving the execution obstruction. So what is the obstruction we are seeing is during the execution, so we can maintain the database consistency, or that is to be identified the preserve database consistency If we are having any kind of obstructions, then we can manage. So this is the point. Preserve database consistency. Yes. Next one is secure. The system needs to control the interaction among the concurrent transactions, and this control is achieved using the concurrent control scheme. So what is the schemes we have? So yes, this is a big question we should have in our mind. What is a concurrent control scheme? So in the next slide, if we have a list of the concurrent control scheme. But before that, let me see the 5th point. Concurrency control has to ensure the seizability. So when we have to improve the seizability in better way, so it is better idea to use the concurrency control. And this is the required part we have to keep in mind properly. Okay, so this is an example I have already discussed while booking a ticket. So we have to keep the all the things properly. So again, I'm not going to in deeply part right now of this example because I've already explained this example over here. This is a while booking the ticket. While booking the ticket, we have the two people, 2 person who want to the ticket, who wants to ticket, but it is finding that only the 1 person can book the ticket. So A will get the chance, or maybe the B can get the chance. So what are the concurrency control protocols? And this is also known as the concurrency control protocol schemes. I can write it here. Concurrency control, this is also known as the concurrency control scheme. So instead of the protocol, you can also use this is known as the concurrency control scheme. Okay. Let me just, okay, it is already correct written. Just correcting, so you can easily understand the scheme. So first one, we have the log-based protocol. Log-based protocol. Next, we have the two-phase locking protocol. Two-phase locking protocol. In this two-phase locking protocol, we will talk about the growing and shrinking. And timestamp-based protocol, we have to see the time-based. We will discuss. And validation protocol, we will see this point right now. And what is the protocol we are using that is a validated or not. So time-based and validation protocol, we will see depend on our syllabus part. If it is a part of our syllabus, so we will discuss as we will focus on the log-based and two-phase locking protocol. Because in the gate examination, two-phase locking protocol is a important point where we can ask the question. So two-phase locking protocol we will see in the next class, but before that, let us understand the log-based protocol. So log-based protocol. Before starting the log-based protocol, just if you have any problem, you have any doubt, so far we have discussed, so please you can ask me right. Just tell me any problem you have, so please you can ask me right now.
No, sir.
No, sir.
Okay. So in simple and concise way, we are looking for all these concepts. So let me explain log-based protocol. From this point, you people are required to use your mind or brain to understand the concept and open your eye and just listen properly. Here from this onward this slide, each and every point is important. So log-based protocol, I'm speaking some terms over here, so please understand the term properly. Each and every term is required. Log-based protocol in database management system is a mechanism in which a transaction cannot read or write the data until it acquire an appropriate log. Okay, so this point I have already discussed while discussing the example. To be remembered of the memory, I'm just taking simple example over here. Suppose this is some rooms. I'm taking very interesting example. I hope this example will clear the more picture. These are the few cells. Okay. So A is, I'm locking the A here, I'm locking the B over here, I'm locking the C over here and D. So these are the data variables, data items. So here A, B, C, R, D, E, F are the my data items over here. And just like you can see, these are the 6 different students I'm locking in a 6 different cells. So if B is a good student, so I'm choosing here from the cell, list of the cells. So what I have to, if I have some bug with the B students, so what I have to do, I have to unlock and uh, I have to move out the B from the cell. Then this B can do the work. So this is just like a data variable. It is just like a data item. So this is B treated as a data variable for me, by which I can perform the operations. So that is the point. So what I'm doing right now, the B can perform the two operations right now, read and write. So with the help of the data item B, I can read and I can write. So B is just this treated as my driven variable by which I can perform the sum operation. So when the A and C and D, E, F and others are locked, so the other transaction cannot be performed on the A, C, D, E, F because these are the locked. But B is unlocked, so we can perform the any operation on the B. So from inspired story, we can do the our log-based protocol inside our database. So that is the point. So log-based protocol helps to eliminate the concurrency problem in database management system for simultaneous transaction. So if I'm releasing the F also, so I can see now I'm just unlocking the F. So now F and B are the two unlocked. So any kind of the operation I can perform on these two data items. Okay, so this is the point. So what is this actually? Lock is what actually? So lock is a data variable which is used by the data items to manipulate the information as our desired. So step by step we will see. So let us understand the concept properly. So log-based protocol helps to eliminate the concurrency problem in database management system for simultaneous transactions by locking or isolating a particular transaction to a single user. Okay. So what is a lock? Lock is a data variable and which is associated with the data item. So what are the data item? So lock is basically what? Lock is name of the protocol. Okay. So I can mark over here. This lock is what actually? Lock is the name of the protocol or name of the scheme. I can say name of the protocol and it is a data variable. Name of the protocol I can see and it is a data variable. While I'm talking about the data items, so data items are required. So this is associated with the data item. So this data item could be A, B, C, D, E, F, as we can see over here. So if you are logged inside your home, so you are not able to move outside the home. Why? Because you are logged. So what I have to do? I have to unlog you by just open the log. Okay, by applying the appropriate key. So that is some kind of thing we can see over here. So this log signifies that a operation that can be performed on the data item. Logs in the database management system help synchronize access to the database item by concurrent transaction. That is a very beautiful term which is written over here, the synchronize access. So log provide or log helps us to synchronization between our data items. Which data item will be applicable to the particular transaction. So that is to be identified by the log unlock data variables. So from this point, we have to identify the synchronization between the each and every transaction property. Let us understand this concept by the help of the other factors as well. So the lock requests are made to the concurrency control manager. A transaction process proceeds only the once the lock request is granted. So here, my dear all students, please listen carefully. Binary locks. We have these two terms, and other one is shared exclusive. So what I mean to say that over here, see this binary lock I'm writing over here. So binary lock we have the two lock. So binary locks. Binary means two, and lock means two locks. So two locks means when we have the lock. So unlike the lock, we have the unlock because we have the two parts. So this is known as the unlock and lock. So a binary lock on the data item can either locked or unlocked state. So this is represented the state actually. Now next we have the shared and exclusive. So what is the mode you want to use to apply on the data item. So this is to be identified by the mode of the lock mode of the lock. So I can write over here locking. Okay, mode of the locking. So this type of the locking mechanism separate the data item separate the logs in the database management system based on their uses. So if a log is acquired, so please underline, sorry, I'm highlighting this point. If a log is acquired on the data items to perform a write operation, then it is called the exclusive log. So it means we have the two types of log over here. One is a log and log, but what is the mode we have? So we have the two types of mode. First one is shared and exclusive. If I'm using the shared log mode, so I can perform only the read operation. So read I can perform only. So this is known as the read only. So read only can be done over here. But while I'm talking about the exclusive, so with the help of the exclusive, I can perform the read as well as the write. I can perform the read and write operations. So these operations are applicable over here. So what is written over here? It is already written over here, and I'm already speaking once again over here. I have already spoken. So now I'm speaking once again. Write operation we are performing. So with the help of the exclusive mode, you are allowed to perform the write operation. Let us understand all these things with the help of the example, so the picture will be clear. Okay. Yes. See, this is the point we have seen already here. So no need to discuss more over here. So what is the things we have to understand? Shared log, just the representative will be the log we have to use, and dash we have to use as S stand for the shared. Okay, and X is what actually X is the data item. S is representing the shared. See, this is the now unlock S. So unlock X. Am I putting the X? So what I mean to set it over here? X is my data item, and I'm unlocking the X, which is the shared mode. Okay, so that is the point. And a shared log is also called a read-only log. So I have already discussed from the my previous slide. Is a read-only log. Unlike the exclusive log, we have to use X rather than the S. So we have the X rather than the S. So what I have to do? Log X. X is a data item inside the bracket or parenthesis. Unlock X means I'm using the unlock in terms of the exclusive mode. So that is the point we have to keep in mind. So no need to discuss more over here. So but what are the examples? Yeah, simple example. For example, if talking about the shared log, if I'm using shared log, so example we can understand if two routine transaction we are using, so account the balance I'm reading. So my father just checking the balance, going to the bank and checking the balance, or asking or request to the bank officer, please show me the balance of the my bank account. But I'm the person who is the account holding, so I have my ATM card, so by which I'm also checking the balance. So what I'm doing, I'm performing two different read operations from the two different transactions I'm performing. First is following by the my father, other is following by the myself only. So this is only the shared log I can use. So I can use. So this is simple thing. This I'm checking the balance. But suddenly I got a chance to that is my father depositing the 1,000 rupees into the my bank account. So what he is doing, he is trying to write the operation on the my bank account, that is updated my bank account is updated by the 1,000 rupees more. So this is what write operation will be applicable over here. I am also reading only. So a read and write operation can be done. Or immediately I can also do the write operation. How? From the ATM card I am withdrawing the 1,000 rupees. So this is to be done. I at the one end I am performing the write operation, other end I am performing the read operation. So at the time what I have the exclusive operation. So that is the point. See, this is to be identified by the simple terms in which we have seen. All these things we can see through our example, so the picture should be clear. So before the concept should be clear, this is the important terms we have to keep in mind. This is summary. In the shared mode, what we have discussed. In the shared mode, you people are required to understand if data is transaction TI has obtained a shared mode locked denoted by the S on the data item Q, then TI can read but cannot write. The transaction TI just can read only the information, but it cannot write. That is the point. But talking about the exclusive, so TI can perform the both operation. So I'm highlighting my points over here. TI is what? That is transaction ID. Okay, so that's the top you have to keep. Yes, this is the point. Yes, this is the point. And this is enter coming to the our exclusive mode. So it is mandatory to understand this point right now when we have to deal with the various numerical point kind of the question we have to see. So this is the point we have to keep in mind, that is known as the log compatible matrix. Okay, so this is a log compatible matrix computation. So where we have the S. So just let me write over here something properly. This is to be identified by the one transaction Ti, suppose that, and this is to be identified these two as assets which identify the transaction Tj. So when we have the as, it means both transactions are supported by the shared mode. So the true will be there. It means sharing also possible. But in the other case, when we have the exclusive mode, then it will not be possible. See, in the exclusive mode, we have the same kind of the mode, and again the false is it. Compatibility false. It means data item sharing will not be applicable in the exclusive mode only. So that is the point we have to understand. This is only theory we have seen so far. So let us understand this example right now. We will understand this example very clearly. So this example will clear all the concept as I'm expecting. So let me write this example perfect. So the picture should be clear to all in concise way. Yes. Let me choose a different colors for explaining my idea. First one, I'm taking the risk. Look at these two transactions. So what we have seen so far theory, I'm just explaining in terms of the solving this problem. First, I'm executing the transaction T1, then I'm executing transaction T2. Okay. So let us assume A has the initial value that is a 100, and B is having the initial value as a 200. So this is our initial values of the A's and B's. So we have noted down these values over here. And now let us choose the first schedule, that is S1, and we have the two schedules. One is the S1 and S2, and this is our part that is known as the T2 and T1. These are the two possible schedules we can have only, either T1 T2 or T2 T1 only. So from the log X, what I'm doing, I'm reading the B value. It means I'm applying the logs operation of the exclusive log operation on the B data item. So I'm reading the B. So here my value will be the 200. I'm doing something, just detecting some its value, so I will get the 50 only. This 150 value will not be updated until unless I use write operation. So if I'm performing the write operation over here on the B, so my final value of the B will be updated inside the disk, that is the 150. And now I'm unlocking the B. So if I'm unlocking the B, so other transaction can use this system, this B value. Else the B cannot be used by the other transaction as well. So I'm doing unlocking. So this is known as the structure of the lock and unlock. Now next time I'm using the log X. So why I'm using the log X? Because from this point I'm reading and writing operation I'm performing inside this structure or block, you can understand. Log X A I'm using. So what is initial value of the read A I can do? I'm using the 100 because it was initialized 100 only. Performing this operation, so my A value will be the 150. Again, I'm speaking once again, my dear student. Until unless using the write operation, I'm unable to update its value. So after performing the write operation, we're getting the A value that would be the 150. So this was a very simple problem where we can get the information. Now I'm applying the unlock. So now this is done perfectly. So now I'm happy. Let us move to the transaction T2. So A was updated by the 150, B was updated by the 150 as well. So you can see that these values. So I'm just marking into the circle. Next, what I have to do, I'm moving to transition T2 just as order I'm following. So T1 transition, just execution of the transition T1 was completed successfully. Now let us move to the transition T2. Here what I'm doing, I'm applying the lock operation on yes. So I'm reading A. So what I can get, I will read the value 150, but because A was already updated inside the disk. So this is the perform perfect. Lock as share mode. Why I'm sharing you? Because I'm just allowed to use only the read operation. If in this case I'm applying the write operation, so I can change the my mode, that is a lock accuracy. So from this case, what I'm doing right now, I'm just reading the B value, so that is 150. And after this point, we have the A and B's value as A and B. So we have now I'm display the A and B. So from this point, I will get the value that will be the 300. Okay. So this is the value. But question was not ended here. The question is saying to over here, can we use the order T2, T1? Yes, of course you can use. So far we have seen this order and let's understand this order right now. So this transaction T2 I'm executing first, so read A. So if I'm reading A, so what is the reading value I can get? 100. Yes, because it was initialized by the 100 and 200 only. Okay. And from this point I can get the B's value that is 200. Because A and B was not updated by the 50, that is to be updated by the transaction T1 only. But I'm choosing the first transaction that is T2 only. So after displaying this point, what I can get the 300. So if I'm choosing the T1 and T2 order, T2 and T1 order, so I'm getting the same result of the display function A plus B. So that is known as the result equivalence. These two transitions are having the result equivalence. And what I'm getting, what I'm able to view, so this is known as the B equivalence. If with the help of the triangle T2 and T1 and T2 T1, if I'm having the value of A and B of last or updated value A and B is 150, 150, so I can say these two transactions are supported by the our view equivalence as well. But there is a no conflicting over here, so we can say there is no conflicting over here. So this is known as the conflict seriability. So there is no conflict equivalence we have over here. So all the things we should clear. Now this picture is clear to all right now. Yes, this is clear to all right now. Let us complete this part right now. So from this point, A and B was the 100. So now B will be the 200 because there was no updation. So after updating over here, so it would be 250. And unlike over here, if I'm reading the A, so I'm getting the 100. So B was updated by this one. So writing A, so I have to do the. So these are the two schedule S1 and S2, T1, T2, and T2, T1 are known as the result equivalence and B equivalence as well. Okay. So that's why there's no guarantee the B equivalence will be always complete equivalence, but complete equivalence will be the part of the or it will be the B equivalence. Okay, so now this is clear to all right now. I'm using log and unlog. Now it is clear to all right now. Yes, tell me. Any doubt over here? So please you can ask. Else this part is clear to all right now.
Yes, sir.
Yes, sir.
Okay. So here we have one more part right now. See this example. So in this case, what the concurrency control manager is doing. So lock X. So first I'm using the lock X, which is to be identified by the transaction T1 and transaction T2. And what is the concurrency control manager will manage all the things? Because here the transaction are not managing, but inside the transaction, concurrency control is also required. So inside the transaction manager, there is a sub manager which is known as the concurrency control manager. So lock X XB. So it means I can perform the read and write operation over here. So log XB I'm using, I'm just directing the B's amount that is 150. Previously I have initialized its value 200. So I'm using the same values over here. I'm unlocking B. There will be no issue. Instead of transaction T2, I'm just log XA. So SS, it means I can perform on the read operation over here. I'm reading A, so that is 100 over here. And now I'm unlocking A. So now T1 just use the unlock B. So it means I have to use the lock B over here. Okay. So if I'm not unlocking B inside the T1 as which is marked by me in circle by the yellow color on the left side, then T2 is not required to lock. But here I was already unlocked, so that's why log s we have to use because I'm performing only read operation. But suppose I'm performing the read and write operation, so I have to use the log xp. So I'm using the b value, so the 150 will come over here. I'm unlocking the b to display a plus b we are getting. But I have already unlocked a, so after moving to the T1 operation, T1 transaction. So because this is concurrent transactions we have over here, so T1, T2, and then T1 I'm jumping back. So log X A I'm using right now, and read B A and write A I'm performing. So A was updated by the 50 only. So you can observe over here the yellow color notation symbol I'm just marking over here. Before using the its addition, before using the addition on the A data item by the 50, I have unlocked the A. I have unlocked A over here, but so that's why we can say I have to apply the again locking protocol on the my data item to apply the its operation read and write operation. So, but ultimately you can observe over here what is the display function is getting. So display function inside the tangent T2 is saying to us, you have already read out the value of the A, so in which we have the 100. You have already read out the value of the B, so that is the 150. So if you're trying to get its summation or addition, so what we are getting the 250. But it should return the 300, so that is the incorrect value. So it is also written over here inside the over this point. So what is inconsistent state? Inconsistent state is saying to us each and every time you are applying the lock and log, so there is no guarantee you are getting the correct result. So it is your brain, it is your idea on which you can apply the locking protocol. So there is a condition, there is situation, there is issues over here. So inconsistent state definitely we are getting through the this point. So unlocking is a part. This is just like example. I'm just moving it to the suppose now I have worked with the B student, so I did the work finally. So now I'm happy. So now I'm unlocking. Okay, now you can't move back. So go back to your shell. So I'm just transforming his to in his cell. That is B. Now I have the work with the C. So I have communicator C. So I'm unlocking the C. So now C is come out. So I have finished the work. So after finishing the work from the C, now again I have to work with the B. What happened at it? I'm again unlock the B and then I'm just calling B again. So this process task is a clumsy or it will waste your time. So this locking unlocking again will is waste your time and it will not provide the better result. There is no guarantee will provide because if the students are very childish nature and then I'm just calling back to the B, okay, now come out and do the other work. So he is just saying no sir, I will not come out. You are unlocked me once, now again you are unlocking me because you have the work. So previously you had unlocked me, so why you are not giving the works again, why you are unlocking me. So this unlocking process will take much time. So that's why this is situation. So that is a point which is written over here. Understand this example. This is the point. Yeah. So unfortunately, locking can lead an undesirable situation. That is the point. Okay, so let's understand all this thing properly over here. So what I'm doing right now, I'm not I'm not applying the unlock data variable or I'm not unlock the data item before ending a task. I'm waiting. Maybe this data item can use again. If I need to again, then I have to apply the lock. So why I'm applying the lock protocol unnecessarily over here? So you can see over here, just let me show my pointer, by which you can easily see. So I'm using the delayed unlocking. So you can observe over here, I'm applying the lock. So if I'm applying the lock, that is transaction T1, you can see observe over here. So I'm transforming T1 transaction into transaction T3. So you can easily say I'm not unlocking over here. So I'm just unlocking at the performing my all the operations. Those are the read and write operations. So you can see my arrow. So I'm again highlighting that over here. That is, so I'm again highlighting this one. So unlocking B I'm applying after the performing all the operations. So this is known as the delayed unlocking. The unlocking will take will be applied at the last. That is the point. Unlocking was the previously on the as its position. Now let us understand this one with the transaction T2. So I'm transforming transaction T2 into the T4 transaction, but you can observe over here unlock A, I'm unlocking A after the performing all the operations. So this is to be done by the delayed unlocking. So this can be resolved by the unlocking delay concept. Okay, so now this is clear to all right now. Suppose in between in the transaction T1 again I need to after read A. Suppose after read A or after write A, I need to read a value of the A B once again. So I will again apply the lock operation, then again read operation, then again perform some activity, transform operation, then again write operation, and then so on. So it will take extra space unnecessarily. So it is better idea to you can unlock your B at the last. So this is known as the not exit at the last, but before closing the is not demanding. If data item is not applicable to the more process, then we can unlock. That is the point. But there is no guarantee it may use. So that's why it is to be identified by the unlocking, delayed unlocking. Okay, so now it is clear to all right now. Yes, tell me. Is it clear to all right now?
Yes, sir.
Delayed unlocking. Yes, good. So after this point, you should verify that sequence of the read and write in the schedule one, which lead an incorrect result, that is a 250. So we got the 250. This was the point. We got the 250. We got the 250. Okay. So being dispatched so is no longer possible with transaction T3 and T4. So other schedules are possible. It means what we have done, we have with this transaction T3 and T4 will try to resolve such issues. Okay, so it was written over here. So this is the part. So now in this case, unfortunately, this is the point I'm highlighting. Please listen carefully. Unfortunately, locking can lead to an undesirable situation. This is the point. This is saying to us if I'm using the tangent T3 and T4, as you can see over the slide. So lock X I'm using and read B I'm using. So from this perspective, what I'm using right now, I'm using the lock XB. Okay, let me write perfectly so I have the picture should be clear. Lock XB exclusive mode I am opening. I'm performing read operation. I'm performing some operation and write operation. So this is okay. But here I didn't use the unlock. Okay, the point you people are required to understand. I'm using the lock as A. In the shared mode, I'm opening. I'm reading the A value and I'm locking the B. So the question is saying to us without unlocking B, without unlocking B, you are trying to use the lock. So again, this is what the person is already inside the cell and then you are applying the lock again, so there will be no sense. Okay, so this is my point. If the person is already inside the room and you say before coming out I'm locking you, but the person is already locked, so there will be no sense. So at that time we will stuck in a situation or in a issue, and that situation is known as the deadlock. This situation is known as the deadlock. Okay, so this is the point. Now this diagram is clear because we have not unlocked the B, and but the transaction T4 is just using the lock B, and same thing is also happening over here. Without unlocking A in the transaction T3 just need to lock A. So that is the reason the situation where we have stuck. So this is the point. Okay, so now this is clear to all right now.
Sir,
Yes, tell me.
can you explain this once again? What is deadlock?
Yeah, deadlock means, see, I can explain over here a simple example. Suppose you are sitting in a room. Okay, listen this example carefully. And I'm logged you. Now you can do your transaction. Okay, you can eat the food, you can spend, you can move anywhere, you can go washroom, you can go kitchen to eat the food. Okay, I'm just locked you inside the room or in your house. After performing the various activity, you will see. Sudden, now next your friend is coming. Then he is saying, you are not required to come outside, so I am locking you. So you are already locked, and I'm again locking you. So there is situation, this is a condition. What happened at the time? You are already locked, so there will be sense, there will be any requirement to lock again? No. So before locking you must be unlocked. So this is the case where we can see observe over here. Transaction T3 was using the lock operation on the B data item, and the transaction T4 using the lock B in form of the shared mode. But in the transaction T3 doesn't unlock the B. So without unlocking a B transaction T4, how transaction T4 can lock the B? This is possible, but this is a condition, this is an issue, this is a challenge where we can face, and this is a situation that is known as a deadlock. So deadlock means the collision may occur. Is it locking, unlocking? Suppose after this point, I'm taking the again back to the my real example. After the unlock, after the sometimes I came to the, I come back to the market. Your friend was locked you, and I also locked you. Now I'm closing, I'm just opening the my lock, but still you are the lock because I don't have the key of your friend's lock. This is a problem. So I will be stuck. I will be in a situation after unlocking you. There will be no sense. You are still in the lock. So this is the point. Okay. So now this is now clear right now.
Yes, sir. So
Okay.
that
This is
means to overcome this problem, if we lock the transaction, then we have to unlock that transaction later.
yes, yes. This is a good point you are picking up right now. Before locking, before applying the locking by the any transaction, your the previous transaction should unlock the use the unlock the data item. So data item is unlocked, then you can apply the lock. Else you are again applying the multiple locking. So there will be a situation that is known as deadlock because on a door I am applying the multiple lock. One lock is used by the father, one lock used by the my mother, one lock used by the myself. After coming back to the market, my father was gone to the some other places. So my mother and my lock I can open, but how I can open the lock of the my father, which is locked by which is lock is applied by my father. So at the time the situation, so again you will be again considered as a lock case. So no number of the locking you number of locks you are applying it doesn't mean, but before applying the any lock you must use the data item that is a part of the unlock. Else there is a situation which is known as the deadlock. Okay, so now this picture should be clear. And from this about the such things, so we have a two facing locking, and this is part we will see in the next class. That is two facing locking.